Dear students, I'm Shinu. I'll be teaching you maths. Today we are going to study the first chapter of maths, rational numbers. You know that there are many numbers such as natural numbers, whole numbers, integers, etc. Before we learn rational numbers, let us revise the different kinds of numbers you have learned in your previous classes. First of all, let us learn natural numbers. Natural numbers are numbers beginning from 1 to infinity. The set of natural numbers is represented by the letter n. The smallest natural number is 1 and the greatest natural number is infinity. Next, let us learn whole numbers. Natural numbers together with 0 form the set of whole numbers. The set of whole numbers is represented by the letter W. W is equal to set 0, 1, 2, 3, etc. The smallest whole number is 0 and the greatest whole number is infinity. Next, let us learn integers. In order to understand the concept of integers, we have to know the number line. On the number line, at the center there is 0. On the left side, there are negative numbers, and on the right side there are positive numbers. The set of integers is represented by the letter I. So, integers is equal to set infinity from minus infinity to minus 3, minus 2, minus 1, 0, 1, 2, 3, up to plus infinity. So it's from minus infinity to plus infinity. So let me revise once again these three sets of numbers that you have learned just now. Let me repeat it once more. First of all, we have learned natural numbers. So natural numbers are also called counting numbers. That means it's from 1 to infinity. That means 1, 2, 3 up to infinity. Then we have learned whole numbers. Whole numbers means natural numbers together with the 0 form whole numbers. The smallest whole number is 0, next to 1, 2, 3 up to infinity. Then we learned integers. Integers means, 0 is an integer. So there are negative integers, there are positive integers. That means infinity, minus 3, minus 2, minus 1, 0, 1, 2, 3, etc. Next, let us learn rational numbers. So let me define rational numbers first. So this is the definition. So a number which can be expressed in the form of P by Q, where P and Q are integers and Q not equal to 0. Such a number is called a rational number. Let me repeat once more. So this is the definition of rational numbers. A number which can be expressed in the form of P by Q, where P and Q are integers and Q not equal to 0. Such a number is called a rational number. Now let's see some of the examples of rational number. So let's see first number 3 by 7. Let's check whether 3 by 7 is a whole number or not. Let's see what is the definition of a rational number. So this is a definition. It should have a numerator, should have a denominator, and both should be integers. And the denominator should not be equal to 0. Let's see 3 by 7. So here the numerator is 3 and the denominator is 7. So 3 is an integer, 7 is also integer. And the denominator is 7, which is not equal to 0. So what we can conclude? We can conclude that 3 by 7 is a rational number. Next, 1. Is 1 a rational number? See, when you see 1, it has no denominator. No, 1 has a denominator. 1 can be written as 1 by 1. Every natural number has a denominator. It is 1. So 1 can be written as 1 by 1. Now let's see 1 by 1 where the numerator is 1 and denominator is also 1. Both are integers. So it is in the form of P by Q, and the denominator 1 which is not equal to 0. Again 1 is a rational number. In the same way, let's say 3. 3 can be written as 3 by 1. So 3 and 1 are integers, and the denominator 1 which is not equal to 0. So again 3 by 1 is nothing but 3. It's also a rational number. Now let's take a decimal, 0.5. Let us check whether 0.1 is a rational number. So can we convert 0.5 in the form of P by Q? Yes, we can convert. Here 0.5 can be written as 5 by 10. It can be simplified. Once we simplify, we'll get 1 by 2, where numerator is 1 and denominator is 2. So it's like it is in the form of P by Q. So what we can conclude that 0.5 is a rational number. Now we are going to learn properties of rational numbers. So there are mainly different properties are there. First is closure property. Now we are going to learn closure property for whole numbers for the 4 fundamental operations. You know that there are 4 fundamental operations are there. What are they? Number 1 is addition, subtraction, multiplication and division. These are the 4 fundamental mathematical operations. What are we going to do? We're going to verify closure property for these fundamental operations for whole numbers. So first of all, let us check what is closure property. For example, let us take any 2 numbers for the set of whole numbers. For that, we need to take any 2 numbers from the set of whole numbers. For example, let us take 2 and 5. And students, you have learned about rational numbers. Now we're going to learn the properties of rational numbers. First of all, we're going to learn the properties of addition for rational numbers. Let's observe the following examples. 5 by 3 plus 1 by 6. Look here, 5 by 3 is a rational number and 1 by 6 is another rational number. What I'm going to do is, I'm going to teach you the closure property for addition. See, we have taken 2 rational numbers. First one is 5 by 3 and the second one is 1 by 6. Before we do, let us check whether these numbers are rational numbers or not. Let's say 5 by 3. Is 5 by 3 a rational number? So let's revise the definition of rational number. What is the definition of a rational number? A number which can be expressed in the form of P by Q, where P and Q are integers and Q not equal to 0. Such a number is called a rational number. Here look at 5 by 3. P is 5 and Q is 3. Here P and Q means 5 and 3 are integers and the denominator is not equal to 0. That means 5 by 3 is a rational number. Second, in the same way, 1 by 6. I hope that you understood 1 by 6 is also a rational number. Now what we're going to do is we're going to take the sum of these two rational numbers. You know, these are fractions. How to add fractions? We need to look at the denominators. If the denominators are same, we can add. We'll add the numerators and denominators will remain the same. Here, the denominators are different. So when the denominators are different, what do we do? We have to take the LCM of the denominators. What are the denominators? Denominators are 3 and 6. What is their LCM? Their LCM is equal to 6. Now, here, so 6 divided by 3, which is 2, 5 2s are 10. Plus, here, 6 1s are 6, so 1 into 6, 6. So you are getting here, 10 plus 6, which is equal to, sorry, it's not 6, it's 1. You know, the denominator is 6, no? 6 1s are 6, so 1 into 1, 1. It's not 6, okay? So 10 plus 1, that is equal to 11 by 6. So this is the sum of 5 by 3 and 1 by 6. Now, look, here we have to check whether 11 by 6 is a rational number or not. So, is 11 by 6 a rational number? Look at the definition of rational number. Denominator and numerator should be integers. Here 11 is an integer, 6 is also an integer, and the denominator is not 0. So 11 by 6 is a rational number. So what is the conclusion? We can conclude that 11 by 6 is a rational number. Okay, so let's take another example. I will take another example. Let it be 1. So this is equal to 2 minus 1 by 3 plus minus 1 by 2. So, okay, negative integers should be inside bracket. Alright, so we are going to do, what are we going to do? We are going to add minus 1 by 3 and minus 1 by 2. Let's see the denominators. So before we do that, let's check. Minus 1 by 3 is a rational number, minus rational number. What are we going to do? We are going to take the sum of these two rational numbers. And what are we going to do? We are going to check whether the sum is also a rational numbers. The same way, first case we have seen 5 by 3, 1 by 6, both are rational number. Their sum, which is 11 by 6, it's also a rational number. In the same way, we are going to verify the sum of these two rational numbers. Here it is minus 1 by 3, next is minus 1 by 2. So the LCM is 6. So here it is 6, 2, then minus 2. So since it is negative number, it will be in bracket, plus here 3 2s are 6, minus 3. So on adding, we'll get minus 2 plus minus 3, that is minus 5 by 6. Now see, the sum is minus by 6. Is it a rational number? See, what's the definition of rational number? So it is in the form of P by Q, and P and Q are integers, and Q not equal to 0. So we can conclude that minus 5 by 6 is also a rational number. It's a rational number. So a rational number. So what do we can conclude? This is a conclusion. When you take any two rational numbers, you add it, the result will be also a rational numbers. Therefore, we can say that for any two rational numbers, P by Q and R by S, their sum, which is P by Q plus R by S, will also be a rational number. So we can say that the set of rational number so therefore we can conclude that the operation of addition on the set of rational numbers is closed. It is nothing but take into rational numbers. Their sum will also be a rational numbers. This is what is called a closure property. Let me repeat once more. So take any two rational numbers, take their sum. Sum will also be a rational number. Clear? Next, we are going to learn the commutative property. Alright? Which property? What is the first property? It was closure property. What is closure property? Means take the sum. The result will also be a rational number. That is what is called a closure property. Next is we are going to learn commutative property. Commutative property of addition for rational numbers. So let me define. Let's take the numbers 1 by 5 and 1 by 2. So let's find the sum of 1 by 5, small 1, plus 1 by 2. What I'm going to do is, I'm going to add the rational number 1 by 5 and 1 by 2. Let's see. Before adding, let's check the denominators. Are the denominators same? No, the denominators are different. So in this case, we have to take the LCM. So what's the LCM of 5 and 2? It is 10. So then 5 2s are 10. So 2 5s are 10. It is 5. So the result will be 7 by 10. So I'm going to take rational numbers changing the order. First of all, it was 1 by 5 plus 1 by 2. Now I'm going to change the order. So I'm going to take the sum of 1 by 2 and 1 by 5. Let's see here. What is the LCM? 10. LCM of the denominators is 10. So this will be 5. 5 2s are 10. Then 2 5s are 10. Again 2. Which is equal to 7 by 10. So look at the result. It is 7 by 10 here. Here also it is 7 by 10. So what's the conclusion? So if you add two rational numbers in any order, the result will be the same. This is exactly what commutative property. So you can add any two rational numbers in any order. The result will be the same. This is what is called a commutative property. So I'll take another example. Again, I am going to add two other rational numbers which are minus 5 by 7. See here, it is minus, so minus integers should be inside brackets, plus minus 4 by 7. So we're going to add two rational numbers, minus 5 by 7 plus minus 4 by 7. See here, the denominators are same, so we'll write the same denominator and we'll add the numerators. So first numerator is minus 5, second numerator is minus 4. So what is minus 5 plus minus 4 is equal to minus 9 by 7. Alright, now I'm going to add these two rational numbers changing the order. That is minus 4 by 7, let it be inside bracket, plus minus 5 by 7. Okay, so denominator is same. Let's add the numerators. That is minus 4 plus minus 5. What is minus 4 and minus 5, that is equal to minus 9 by 7. Alright, let's see here. Even in the first case we got minus 9 by 7. Even in the second case we got minus 9 by 7. What does it show? It shows that the result is the same. So this is what is called a commutative property. So let's conclude. What does it mean? Commutative property means you can add any two rational numbers in any order. The result will be the same. Alright, this is it. Now we are going to learn associative property of addition for rational numbers. In this case, instead of two numbers, there will be three numbers. In this case, numbers are rational numbers. So we are going to add three rational numbers. Okay. So these are the three rational numbers: 1 by 8 plus 3 by 7 plus minus 1 by 7. 1 by 8, 3 by 7 and minus 1 by 7. So I'm going to group first and second, and then I add first and second, and the result will be again added with the third number. Let's do here. Here in case 1 by 8 plus 3 by 7, the denominator is 50. So the denominators are 8 and 7. So since the denominators are different, we have to take the LCM. What's the LCM of 8 and 7? It is 56. Okay. Now let's find the numerators. 8, 7s are 56. So 1 into 7, 7. Plus here 7, 8s are 56. So 8 3s are 24. Okay. This is the sum of 1 by 8 and 3 by 7. So the result is to be again added with the third rational number, that is minus 1 by 7, right? Minus 1 by 7. So this is 24 plus 7 is equal to 31 by 56 plus minus 1 by 7. Again the denominators are 56 and 7. The denominators are different, so we have to take the LCM. LCM of 56 and 7, which is nothing but 56. Okay, so the numerator of the first rational number or fraction will be the same, 31. Here 7, so 8 7s are 56. So 8 into minus 1, which is minus 8. So that is equal to 31 plus minus 8, which is equal to 23, right? Plus 23 by 56. This is the result. So I have added, taking first and second, then with the third one. So what we are going to do is we are going to add the same rational numbers in a different way. So what I'm going to do is I'm going to add these rational numbers, this time second and third first, and the result will be added with the first one. So let's add second and third first. So 1 by 8 will be the same, plus, alright, we are going to add 3 by 7 and minus 1 by 7. So what's the denominators are 7 and 7. So the same denominator 7. Numerator will be 3 plus minus 1, right? So that is equal to, okay, 1 by 8 will remains the same, plus 3 plus minus 1. What is 3 plus minus 1? It is equal to 2 by 7. Now we have got the result, which is 2 by 7. Again we'll continue adding. So here the result is, okay, denominator 56, this is equal to 7, plus here it is 8 2s are 16. So that is equal to 23 by 56. So let us analyze the result. The first case also we got 23 by 56. Even in the second case also we got 23 by. Conclusion, result is the same. That means for three rational numbers you can add in any order. The result will be the same. This is what is called the associative property. Now let's learn additive identity. Okay, what are we going to learn? We're going to learn additive identity. Let's see. I'm going to add 1 by 7 and 0. Alright, you know that if you add any number with 0, the result will be the number itself. So 1 by 7 plus 0, it is equal to 0 plus 1 by 7. What is that? According to which property? Commutative property. That means two rational numbers can be added in any order. The result will be the same. So 1 by 7 plus 0, it is equal to 0 plus 1 by 7. That is 1 by 7. That means in this case 0 is called the additive identity. Right? You can add any rational number with 0. The result will be the rational number itself. So 0 is called additive identity. Let's see one more case. So here minus 1 by 2. Okay. Plus 0. It is equal to 0 plus minus 1 by 2. Okay. Which is equal to minus 1 by 2. Okay. Now what are we going to learn? We're going to learn additive inverse. Okay. So let's carefully observe the following examples. I've written here 1 by 9 plus minus 1 by 9. What is the result here? 1 by 9 plus minus 1 by 9. Let's see. The denominator is the same. The numerator will be 1 plus minus 1, which is 0. The result will be 0. That means 1 by 9 plus minus 1 by 9 is equal to 0. What is 0? We have learned 0 is the additive identity. So in this case, we can say that minus 1 by 9 is the additive inverse of 1 by 9. In the same way, we can say that 1 by 9 is the additive inverse of minus 1 by 9. Let's see another example here. 3 by 5. So 3 by 5 plus minus 3 by 5. What is the sum? Denominator is 5. Numerator 3 plus minus 3. So which is equal to 0. 0 is the additive identity. What is the conclusion? That means minus 3 by 5 is the additive inverse of 3 by 5. Alright. Generally we can say that if there is a rational number p by q, it will have an additive inverse which is minus p by q, so that their sum, which is p by q plus minus p by q, is equal to 0. Okay, children, this is enough for today. So let us recall all what we have learned today. So first of all, we have learned the definition of rational number. So, okay, what is a rational number? A rational number is expressed in the form of p by q, where p and q are integers and q not equal to 0. Such a number is called a rational number. Secondly, we have learned the properties of addition for rational numbers. So the first one was closure property. What does it say? Means if you take any two rational numbers, their sum will be again a rational number. Then we have learned commutative property. What does it say? Means commutative property means two rational number can be added in any order. See, if p by q and r by s are two rational numbers, p by q plus r by s is equal to r by s plus p by q. That means two rational numbers can be added in any order. the result will remains the same. Then we have learned associative property. Associative property means when there are three rational numbers, we can add these three rational numbers in any order. That means you can add first to two, then you can add the result with the third one. Alright, the same way you can add first and last one. Again with the second one, the result will be the same. Next you have learned additive identity. So 0 is the additive identity, right? Then finally we have learned additive inverse. That means for every rational number p by q, there will be an additive inverse which is minus p by q, so that p by q plus minus p by q is equal to 0. That's all for today.